Our discussion thus far has focused entirely on the parts of the nervous system responsible for processing sensory or incoming information. We've learned that a sensory system consists of sensory receptors, which trigger activity in cascading neural pathways. We've followed these pathways through many distinct parts of the old and new brain involved in sensory perception. Tracing a visual percept, for example, from its humble origins as a spray of photons hitting the retina to its high-level representation beyond V1. And traveling alongside an auditory stimulus as it vibrates the eardrum to begin a cascade of mechanical and ultimately neuronal action, giving us access to a rich sense of the sonic environment around us. Clearly, our brains put a huge amount of time and energy into collecting and interpreting signals from the environment. But although it's nice to be able to observe things around us, we're also active creatures. There'd be little point in collecting all this great sensory information if we couldn't act on it. That's where the motor system enters the picture. The motor system is what allows us to take the information we process through sensory pathways and use it to inform our behavior. It's what makes all those complex sensory circuits worth the trouble. Thanks to the motor system, we can reach towards food that our olfactory system senses, and jump away from a snake that our visual system sees. Indeed, without a functional motor system, we'd be helpless. We can see this firsthand in diseases of the motor system. When the motor system degenerates, severe dysfunction ensues. Patients with total locked-in syndrome, who are paralyzed in essentially all voluntary muscles, must be cared for round the clock by others, although cognitively they remain perfectly intact. Many even retain sensation, yet they can't feed, relieve, or hydrate themselves. In such patients, incoming sensory cues, for all their complex circuitry, no longer serve much of an evolutionary benefit. So with our strong foundation in sensory systems that inform adaptive action, let's begin to probe the system that allows that action to occur. The idea that separate systems exist for sensing the environment and acting on it dates back to ancient times. Ancient medical practitioners, such as the Greek neuroscientist Claude Galen, living centuries before the Common Era, already understood that the nervous system essentially served two functions: sensation and movement. Indeed, Galen, born in 130 BC, confidently described the brain as an input-output center, receiving sensory information and generating motor commands. Now, centuries later, this idea of the brain in terms of input and output is deeply embedded in our understanding of the brain and its subsystems. And just as we have pieced together bits of the sensory puzzle by following signals as they move from sense organs through complex pathways of information flow in the brain, so too have we cobbled together a mental model of the motor system, with signals originating in the brain and ultimately driving movement in our bodies. However, while it might be tempting to begin at the beginning of the motor system, starting from the origin of a motor action in the brain and tracing outward and forward in time, the truth is that we don't yet have a clear picture of where a motor command begins, or whether that's even a well-posed question. Instead, our understanding of the motor system has largely proceeded from the outside in, tracing from our muscles inward through the peripheral nervous system and ultimately to the brain, effectively tracking the flow of information backwards in time. And just as in the brain's sensory system, our understanding is in many ways clearer closer we get to the outside world, with the action of peripheral neurons being reasonably well understood, and with the flows of information becoming more and more mysterious as we move to cerebral cortex. In many ways, sensory and motor neuroscientists today are attacking the brain from two sides, with the hope that we'll someday meet in the middle, synthesizing a unified understanding of how perception shapes action and vice versa.